Today I'm going to be showing you about the production possibility frontier. Our goods are knitted mittens and paper planes. In 1 hour, I can make either 3 knitted mittens or 15 paper planes. My friend can make either 5 knitted mittens or 10 paper planes. Assuming we have a 10-hour workday, I can make up to 30 knitted mittens or 150 paper planes, and my friend can make either 50 knitted mittens or 100 paper planes. So going specifically to me, we can divide up the labor, which would be 10 hours. So we could put 8 hours towards knitted mittens and 2 hours towards paper planes, or I could put 5 hours towards knitted mittens and 5 hours toward paper planes, or 2 hours towards knitted mittens and 8 hours towards the paper planes. As long as I don't go past 10 hours, because that's how many hours I have in my workday. So let's say I go with 8 and 2, then I make 3 in 1 hour, and so 8 times 3, 24, or then 2 times 15 is 30. This is how we get these numbers over here for the production. And it depends how we divide up the hours worked. Then this is my own personal production possibility frontier, and at 10 hours without working on any knitted mittens, I can make 150 paper planes, and at 10 hours without working on any paper planes, I can make 30 knitted mittens. And so when you have a production possibility frontier, once you have the graph, it's pretty easy to find the slope, and finding the slope is important because the slope equals opportunity cost. And so and the slope is always rise over run. So we have negative 150 over 30. It's a negative 150 because the slope is not rising, it's falling down. So that's why it's negative 150. So negative 150 equals negative 5. Negative 150 over 30 equals negative 5. And then that becomes 1 knitted mitten equals 5 paper planes. And that's my opportunity cost. So whenever I make 1 knitted mitten, I could have been making 5 paper planes. And vice versa, whenever I make 1 paper plane, I could have been making 1/5 of a knitted mitten. So now we're going to move over to my friend, who, same thing, divides up the labor, 8 hours towards knitted mittens, 2 hours towards paper planes, 5 hours towards knitted mittens, 5 hours toward paper planes, and then you just, so 8 hours for knitted mittens, and then he can work 5 knitted mittens in an hour, and so then 8 times 5, that gives you 40, and then so on and so on. Here's the rest of it there. This is his production possibility frontier. He can make 100 paper planes if he doesn't work on any knitted mittens, or he can make 50 knitted mittens if he doesn't work on any paper planes. So we get negative 100 over 50, again because the slope is going down, and then that gives you negative 2. So then 1 knitted mitten, when he makes 1 knitted mitten, he could be making 2 paper planes, or whenever he makes 1 paper plane, he could have made half a knitted mitten. Now we're going to compare both graphs together. These are both the graphs on the same graph. On line 1, my friend is line 2. We have just the information we just discussed there. So now we're going to talk about absolute advantage. Absolute advantage would be me, going back to the first one here, I can make 15 paper planes while my friend can only make 10 in an hour. So that gives me the absolute advantage for paper planes. But because my friend can make 5 knitted mittens in an hour and I can only make 3, he has the absolute advantage there. So it's right there. absolute advantage, paper planes me, knitted middens friends. Then we move over to comparative advantage. Comparative advantage is different from absolute advantage because comparative advantage has to do with your opportunity cost. And so if it's a lower cost for you to make knitted middens than it would be for me, as is the case for my friend, it's a lower opportunity cost because whenever he makes one knitted mitten, he's only missing out on 2 paper planes. But whenever I make one knitted mitten, I'm missing out on 5 paper planes. So the opportunity cost for him is lower, so it's more cost efficient for him to focus on making more knitted middens. So then we have a consumption without trading. So without trading, you want to divide up your resources equally. So let's say I put 5 hours towards both goods, then I would have 15 knitted middens and 75 paper planes. And if my friend did the same thing and put 5 hours towards both goods, he would have 25 knitted middens and 50 paper planes. And so now let's look at consumption with trade. Let's say I put 7 hours towards paper planes and 3 hours towards knitted middens because I have the comparative advantage there, and I know that my friend has the comparative advantage for making knitted middens, so we can just trade with each other. So I would get 105 paper planes and 9 knitted middens, and my friend putting 7 hours towards knitted middens and only 3 hours towards paper planes would get 30 paper planes and 35 knitted middens. Now, I still haven't met my consumption because I'm only at 9 knitted middens when I need to be at 15 because that's where we were without trade. So I import 6 knitted middens from my friend. He exports 6 knitted middens to me, and then that leaves me with 15 knitted middens and my friend with 29 knitted middens. Then my friend is short paper planes because he normally would have 50 paper planes, but now he only has 30 paper planes. So I export 20 paper planes to him and he imports 20 paper planes. And so the amount left is the amount consumed, and I have 85 paper planes and 15 knitted middens, and my friend has 50 paper planes and 29 knitted middens. And we can compare that to without trading. We can see that it's the same amount of work, still it's a 10-hour workday, and I have 15 knitted middens and 75 paper planes, and I'm able to increase my paper planes just by trading and not doing any more extra work.